Welcome back to my channel. Today we're going to talk about polynomials. So we're gonna try to find the equation of polynomial based on the graph. And so just some introduction to polynomials. We have learned linear functions like y equals to mx plus b. We learned quadratic functions like y equals to ax squared plus bx plus c. And we also learned about exponential functions where we have a to the power of x. But in polynomial, a very special thing about polynomial is that it has a wide variety of these things. So what I mean is we have, for example, 2x to the power of 7 plus 8 to x to the power of 4 plus 3x plus 4, something like that. This is what you call a polynomial. And here, some vocabulary or terminology that would be useful. We have in polynomials something called a degree. So a degree basically means the highest power. So here we have power of 7, power of 4, power of 1, and also power of 1. And the degree is the highest power. So what that means is here, and the highest power is 7. So we know that the degree is equal to 7. And then we know that the coefficient of the highest degree would be then 2. So this is something useful because the degree in future or in future tests or exams, the word degree often appears when it comes to polynomials. So it's good to know what that means. So now we're going to look at in polynomials we have something else called multiplicity. So multiplicity, there's odd multiplicity and even multiplicity. And when it is an odd multiplicity, it means that the graph will cut through the x-axis, and when it's even, it will not cut through and bounce off the x-axis. So what I mean is, let's take a look at graph A here. We see that in the x-axis, on this line, we have 2 points at -1 and 1. The first one here, we can see that the graph goes through the x-axis, while on the other hand, the graph doesn't go through the x-axis. Instead, it bounces off the x-axis. So what that means is when we have something that crosses the x-axis, we have an odd multiplicity. So that means that the power must be odd. Let's pull that down. And when it bounces off the x-axis, we have an even multiplicity. So whenever it goes through the x-axis, odd. Whenever it bounces off, even. So it can also be when we have a graph, when something bounces off the x-axis, that is an even multiplicity. And as you can see, this looks like the quadratic function, right? So you can tie that with your previous knowledge about quadratic function where we have x squared. We have an even multiplicity. Oh, oopsie. So once we know whether it's odd or even multiplicity, now I want to focus on writing an equation with the zeros. So we know that in quadratic formula, whenever we have 0, for example, like a 0 here and a 0 here, for example, if this is -1, 0, this is 1, 0, then we know that our equation is going to be something in front that determines whether it compresses the graph or stretches the graph. But we know for sure that we have the factors x plus 1 times x minus 1, because we have in factored form, this shows the zeros. So the same thing also applies to polynomials. So in polynomials, here we have 2 zeros, right? At x1 at the coordinates -1, 1 and 1, 1, 0. Sorry, I think I said something wrong earlier, but what I meant was we have two zeros at point -1, 0 and 1, 0. So like I said earlier, we can use factor form to write that out. So I have x plus 1 times x minus 1. And then we have a value a in front. Now, I mentioned about odd multiplicity and even multiplicity. So odd multiplicity means that the power is going to be an odd number. So here, this corresponds with this 0 here. And we know that it's odd multiplicity. So it could be either to the power of 1, to the power of 3, to the power of 5, to the power of 7. You get what I mean. But we know that this is definitely going to be 1, because when it is 3, the graph, instead of going like just going through like that, it will look something like, it will touch that, but it will look something like this. So we know, for example, when we have a graph like that, we know that you can also try this in decimal. It will look something like this. It's an odd function. But in this case, we don't see that kind of shape here. We don't see that kind of S shape here. So we know that this has to be 1. And then we have even multiplicity where it bounces off. So we know that this is going to be either 2, either 4, either 6, either 8. And you get what I mean. We have the power that's definitely going to be even. And in this case, we know that it's going to be 2 and not 4 or 8, because we can see that the shape looks similar to 2. And sometimes I would say in this case, it's okay to assume a bit to determine whether it's 2 or 4, because when it's 4, we know that the graph will look kind of more, when it approaches the x-axis, it will be, instead of like a quadratic function, it will instead kind of plateau at the x-axis. So then we know that this is going to be 2. So now we're so close to finishing. Now we just need to solve for a. So how do we solve for a? Well, we're given a point here at 0, -1. So I can plot that point and solve for a. So if we know that y equals to a times x plus 1 times x minus 1 squared, then we plot this, we substitute these points in to solve for a. So I know that y is equal to -1, and x is equal to 0, so 0 plus 1 to the power of 1. I can just leave it like that. And 0 minus 1 squared. So I have 1 times -1, this becomes -1 squared, and -1 times -1 is just 1, so I know that this is just going to be 1, and 1 times 1 is just 1, so it's just going to be a equal to -1. So our final function, or our final equation, would then be -1 times x plus 1 times x minus 1 squared, or I could just write it as like that without writing the 1. And there you have it. We have our first equation. Now let's try moving on, and you can also pause the video and do it yourself. Here I see 3 zeros. Here, 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 and here. And here we know that this is even multiplicity because it bounces off. How about here? This is an odd because it goes through the x-axis. And this also odd. So we have the 0, so we can use factor form. We have some sort of value a, and in factor form we can write it as x plus 2 because this is -2, and then x minus 2 because this is 2, and x minus 3 because this is 3 here. So now I have this here, and I want to make sure to add my powers based on the multiplicity. We know that this bounces off, so that we know that this is going to be 2 and even multiplicity, and then we just leave these powers as just 1. So now I want to solve for a, and again I'm given a point here, so I can solve this by substituting the values. So y is -3, x is -1. So I plot or substitute those numbers in and solve for a. So I have -1 plus 2 is just 1 squared. -1 minus 2 is -3. -1 minus -3 is -4. And then to simplify that, I get 1 times 1 is just 1. So 1 times -3 is -3. -3 times -4 is 12. So I have 12a equals to -3. And I get a as -3 over 12. To simplify that, I get -1 over 4. So the new equation would then be -1 over 4 times x plus 2 squared, x minus 2 times x minus 3. And there you have it. Last but not least, we have this graph here. Again, we have two zeros. This time we know that this 0 here is even because it bounces off, and this also bounces off, so we know that they're both even multiplicity. So I have some sort of value a, x plus 4, x minus 3. Remember to add the powers. We know that they're even, so the powers have to be even. So to solve for a, again, we're given a point here at 0, 4. So we know that y is equal to 4 and x equals to 0. We plot the numbers in, and 4 squared is, or I'll just solve for this first. Okay, so 4 squared is 16. -3 squared is 9. So 16 times 9 is 144a equals to 4. And to solve for a, it's going to be 4 over 144. And when we simplify it, we get 1 over 36. So our new equation would then be 1 over 36 times x plus 4 squared, x minus 3 squared. And there you have it. That's the video on polynomials. I hope you enjoyed it. Some final key takeaways are, when you find formulas for a polynomial based on the graph, you want to see whether it crosses the x-axis or not. If it does not cross the x-axis, if it crosses the x-axis, it is an odd multiplicity. If it bounces off like a parabola, then it is an even multiplicity. And then once you have the factored form, you also want to solve for the value a to determine the shape of the graph, and you use the points that you're given and substitute it into the equation to solve for a, and then you get a new equation. I hope this video helps, and have a nice day.